An audit is not a correction. A correction is not a validation. A successful build is not proof. And an AI agent saying the work is complete is not the same thing as evidence that the work is complete. That distinction became the center of the second stage of rebuilding my book, FX options and volatility trading, pricing, hedging, and volatility strategies. The manuscript had already been audited. That was episode 1. The audit produced 1,003 findings. 34 of them were classified as P0, the most serious category, not questions of taste, formulas, numerical results, financial interpretation, decisions that could not safely be left ambiguous. The task was no longer to find the problems. The task was to build a process capable of proving that each critical repair was correct. This is the Post-Project World. I'm Luigi Pascal Rondanini, and this episode is called From Audit to Evidence. In episode 1, I argued that an agent may perform work, but it should not define the conditions under which its own work is trusted. That principle sounds abstract until the work involves a technical manuscript of several hundred pages. The completed audit identified 34 P0 findings, 424 P1 findings, 545 P2 findings, 1,003 in total. The P0 category had to be handled first because it contained the defects with the greatest potential to alter meaning. It would have been easy to ask a model to fix all critical issues. It would also have been irresponsible. A single large prompt would have mixed formula repair, numerical correction, editorial judgment, typesetting, validation, and publication control into one opaque operation. So the P0 work was divided into controlled batches. Batch A covered 22 formula and economic findings. Batch B covered 8 numerical findings. Batch C covered 3 decisions requiring explicit author approval. That left one final P0 item, the index and pagination finding. It was not forgotten. It was deliberately deferred, because an index cannot be locked honestly while the book is still changing. Which gave us a precise target: 33 critical findings to implement now, one critical finding preserved as open until the correct stage. The rebuild was performed in a separate Git repository. The original source stayed apart from the controlled rebuild. Every approved stage had a commit, a clean status, and, where appropriate, a tag. The repository became the control plane. This mattered because the process needed to answer questions a normal editing session cannot answer. What changed? Why did it change? Which audit finding authorized the change? Was anything else altered? Can the previous state be reproduced? Can the work resume safely after failure? The implementation and review roles were also separated. One model configuration performed implementation, a different configuration performed adjudication and independent review. The distinction was not based on a belief that one model is infallible and the other is not. It was a governance decision. The same role should not silently define the requirement, implement the change, and approve the result. Each batch was bounded by an explicit finding list. Work outside that list was prohibited. That sounds restrictive. It was meant to be. Scope control is not an inconvenience when hundreds of technical corrections remain. It is what prevents one repair from becoming an undocumented rewrite. Then the implementation crashed. The first formula batch stopped while working in chapter 24. At that point, 11 chapter files had uncommitted modifications. Some calculation suites had passed. Chapter 23 had completed 40 out of 40 checks. Work had begun on 3 chapter 24 findings. But the final implementation report did not exist. The final validation file did not exist. There was no completed gate. This created a useful test of the process. If the workflow depended on the agent remembering what it had done, the work was lost. If the workflow depended on durable state, it could recover. The recovery run was instructed to inspect the Git diff, the logs, the approved manifest, the current source, and any generated outputs. It had to classify every one of the 22 formula findings according to its actual state, not started. Source edited but not validated, calculation validated, compiled but not visually inspected, complete but uncommitted, complete and committed, or blocked. The recovery was not allowed to restart blindly. It had to preserve valid partial work and continue from the first incomplete validation step. That is a small but important difference. A restart repeats activity, a recovery reconstructs state. For each critical correction, the workflow required deterministic recalculation. The model could explain the result, but the result had to be reconstructed from explicit inputs in code with intermediate values, tolerances, and publication rounding on record. The tests were designed to fail when the manuscript and the calculation disagreed. The independent final review then reran the entire suite, every chapter, every appendix group, every batch. Every suite completed with 0 failed assertions. This was particularly important where a plausible sentence could hide a material technical distinction. One finding concerned tail risk measures. The corrected text had to distinguish an expected shortfall of 25.6 million euros derived from a generalized Pareto distribution from an empirical conditional value at risk of roughly 13.7 million euros. Those are not interchangeable labels for the same number. Another finding concerned the risk budget conclusion. The corrected values were $6.08 million and $3.26 million. Against a $3 million budget, the exotic position fails the limit. A numerical repair that left the old passes conclusion in the prose would still be wrong. The test was therefore not only, is the number right? It was also, does the conclusion now agree with the number? All 3 batches produced clean builds. The final review compiled the manuscript to 780 pages at 7 by 10 inches with no fatal error. But a compiled PDF was still not enough. Compilation only proves that the typesetting engine could produce a document. It does not prove that formulas are readable, that tables have not broken, that symbols are present, that a corrected number has not disappeared into a layout defect. So the review derived a complete set of pages affected by the 33 implemented findings, 31 unique pages. Every one was rendered directly from the final PDF at 300 dpi for a 7 by 10 inch page that produces an image of 2100 by 3000 pixels. All 31 pages passed visual review. No clipping, no overlap, no broken table, no missing mathematical symbol in the corrected regions, no stale contradictory value left behind. The resolution rule itself emerged from a failure in the process. Earlier validation renders had been produced at 150 dpi, useful as previews, not strong enough as final publication evidence. So the policy was made explicit. Final validation renders at 300 dpi or better, raster line art at 600 dpi or replaced with vector artwork. And the low-resolution source does not become publication-ready simply because someone enlarges it. One more lesson from this stage, and it is my favorite. At one point, the raw build logs appeared to show that the critical repairs had introduced 67 additional overfull box warnings. The approved baseline showed 251 raw warnings. The rebuilt manuscript showed 318. Taken at face value, they looked like a typesetting regression. But raw warning totals were being counted across multiple compilation passes. When the logs were deduplicated by source file, line and overflow width, both builds contained exactly 107 unique warnings. the same 107, genuinely introduced by the repairs, 0. This is why evidence needs interpretation. A number in a log is not automatically a fact about the manuscript. The method used to count it is part of the fact. After all 3 batches were complete, the whole critical phase was reviewed independently. The review reconciled the full set, 34 approved critical findings, 33 implemented and closed, 1 deferred, no missing identifiers, no duplicates, nothing incorrectly included. It parsed every validation file with 2 independent parsers. It reviewed the complete source diff from the approved baseline. It reran every calculation suite. It rebuilt the book. It compared warning sets. It rendered and inspected all 31 affected pages. It checked that no batch had introduced a new low-resolution publication image. And it issued a final decision. Pass. The critical remediation is independently approved. That approval does not mean the book is ready to publish. It means something narrower and more useful. The critical remediation phase now has sufficient evidence to be trusted. Here is what remains open: 424 P1 findings, 545 P2 findings, 146 embedded images below the publication resolution threshold, external claims requiring verification, a whole book regression audit, the final index and pagination lock, publication pre-flight. The distinction matters. A weak process celebrates the completion of a batch and quietly converts it into a claim about the whole product. A governed process preserves the boundary. The critical gate passed. The book did not yet pass. The lesson from this stage is not that AI can repair a technical book. It can contribute to that work. The deeper lesson is that technical confidence comes from the surrounding system, a fixed scope, an approved manifest, separate implementation and review roles, deterministic calculations, durable logs, recoverable state, source control, visual inspection, explicit deferrals, and a gate that can still say no. The agent did useful work, but the evidence made the work trustworthy. And the evidence existed because the agent was not the control plane. The full field notes are on the OrbaOS site and on Medium. Links in the episode description, along with details of the book at rondanini.com. I'm Luigi Pascal Rondanini. This has been the Post-Project World. Episode 2, From Audit to Evidence.